This is 1.5 about measuring segments. Since we already know what segments are, we're going to learn about a postulate that tells me that if I've got two segments here, such as EM and ML, that are connected together, then the sum of those two segments should equal the entire length of the segment. And you can see that postulate in your book if you need to. So let's take a look at this problem. It says if segment EL is equal to 60, find the value of x. Now, the only thing I know here, just by notation alone, not without using any numbers yet, is that I should see that EM, segment EM, plus segment ML should give me the entire segment of EL. And that should make some sense. So what I'm going to do next is I'm going to do some substitution. I know the length of segment EM, not in terms of a number, but I do know that it's the same thing as 3x minus 12. So I'm going to go ahead and rewrite this as such. I'm going to write 3x minus 12 in place of that segment notation. And then I'm going to write the next piece as whatever ML is, which is 2x minus 8. And I actually know the length of EL. It says right up here in the problem that it is equal to 60. So I'm going to set this equal to 60. Now, since all we're doing is adding these two expressions, the parentheses have no real value. So I'm going to go ahead and rewrite this and drop the parentheses. And I'm going to also eliminate the color coding since I don't need it so much anymore. So I'm going to continue this right down here. I'm going to go in a linear fashion. So 3x minus 12 plus 2x minus 8 is equal to 60. So I didn't do anything special. I just took the parentheses away. So we're going to use our algebra skills here to find like terms. And I do see that 3x and 2x are like terms, and both of them are positive, so 3x plus 2x gives me 5x. And my other like terms that I see here are going to be the constants, which are negative 12 and negative 8. When I combine those two terms, I get a negative number, and it is negative 20. And we haven't done anything to the right-hand side here, so I'm going to leave it as 60. Now, in order to solve this equation, I am going to cancel this minus 20 by doing the opposite, which is addition, so plus 20 here, and plus 20 here. So negative 20 plus 20 is 0, which will cancel that out. I'm going to bring down this 5x. I'm going to look over here on the right-hand side. 60 plus 20 happens to be 80. Now, this 5x means 5 times x, so what do I need to do to cancel multiplication? That would be division, so I'm going to divide both sides by 5. And 5 divided by 5 is 1, which I want. I want x to be all alone. So x is equal to whatever 80 divided by 5 is, which is, I'm having a brain fart here. Let's see, 16. So there we have the segment addition postulate. That sums it up. It just tells you that two segments, when they share this midpoint, not the midpoint, but this center end point, that you can do this process to determine a missing variable.